Hey there, students, and welcome back. Today we're taking a look at Topic 11, Block 4, and we are solving linear equations that involve all different kinds of mathematical operations. And so we're just going to get started with a little bit of review. So let's take a look at our very first review question. 3 multiplied by the quantity x plus 5 equals 27. So I'm going to rewrite that so I have more room. Okay. Well, there are a couple of different ways we could solve this one. I am going to choose to solve it using distribution first. So I am going to distribute the 3. That means I'm going to multiply it by everything that's inside my parentheses. So 3 multiplied by x, that's 3x. And then 3 multiplied by 5 is 15. And because that's a positive 5, that's going to be positive 15, or plus 15. And that's going to equal 27. Now I can solve this two-step equation, first of all, by undoing the addition that we see here. It is adding 15, so I have to undo that addition by subtracting 15 from both sides of my equation. And when I do, 15 minus 15 is 0, so I have 3x only on this side. And 27 minus 15 is 12. Okay, and now this is 3 times x equals 12. I want to get x all by itself, so I have to undo that multiplication by dividing by 3. That 3 and that 3 cancel each other out, leaving me with x equaling 12 divided by 3, which is 4. All right, and of course, if I want to check my work, I can always go back, take that 4, put it back into my original equation, simplify that expression, and see if indeed what is on the left-hand side of my equal sign is equal to what is on the right-hand side. All right, well then let's move on from there to the next question. That's negative 4x minus 6 equals 2. So I'm going to rewrite that. Negative 4x minus 6 equals 2. Okay, well, we don't have any distribution to perform, and so remember, we are working backwards through the order of operations, and so we'll write that down here, order of operations, PEMDAS, and that means that because we're working backwards through, we have to do the opposite. So any addition or subtraction that you see must be undone first. I see here that I have negative 6 or minus 6, so I'm going to do the opposite of that, and I'm going to add 6. Now the reason that I do that first instead of multiplying or dividing by negative 4 is that I have to undo the addition or subtraction stuff first. Okay, now I'm adding 6 to both sides. 2 plus 6 is 8. And that means I bring negative 4 times x down. My next step, this is negative 4 times x equals 8. So I am going to divide by negative 4 on both sides. When I do that, those two cancel out, and I'm left with x equaling 8 divided by negative 4. Now that's a positive divided by a negative, which means I'm going to have a negative quotient, and 8 divided by 4 is 2. Now, remember, when you get to the end and you've got your answer, you can always take that answer and put it back in for x and see if what you have on the left-hand side of your equation equals what you have on the right-hand side of your equation, simply by substituting negative 2 for x. All right, well, let's move on to the third one here. This is negative 1/3 times x plus 8 equals negative 1. Now this one, it's not a whole lot different than what we've done already. I'm going to rewrite it, of course. Equals negative 1. Okay. First things first, I'm going to undo the addition of 8 by subtracting 8. Those two cancel each other out, and I get negative 1/3 x equals negative 1 minus 8. That's the same thing as negative 1 plus negative 8, which is negative 9. So now I have negative 1/3 times x equals negative 9. Now I have to divide by negative 1/3. But remember what division is, especially when it comes to fractions. It is multiplying by the reciprocal. So I'm going to multiply both sides of my equation by the reciprocal of negative 1/3. And that would be negative 3/1. And this side, negative 3/1 is just negative 3. So I don't need to change that to a fraction because I'm multiplying it by a whole number. Now, when I get to that point, this one and this one cancel each other out, and I am left with x over here, and negative 9 times negative 3 is positive 27. And I'm done. Again, you want to check your answer. You can by taking that 27 that we found for x, substituting it back into your original equation, and see, does the expression on the left-hand side equal the number that's on the right-hand side? All right, well, this one here, we have an interesting equation. It's got a lot of stuff going on. We're just going to start from the very beginning. And let's see here. So I have 2 times 3x plus 4 plus 5x equals 41. Okay, first step. I am going to distribute. I need to simplify this side of my equation. I'm going to distribute 2 into the 3x plus 4. So 2 times 3x is 6x, and 2 times positive 4 is positive 8. And then plus 5x equals 41. Now, I can combine my like terms, and when I do that, I can rearrange these if I want to and say, all right, well, I'm going to say 6x plus 5x plus 8 equals 41. See how I grouped those two together? Because they are like terms, they have the same variable raised to the same exponent. Now, 6x plus 5x is 11x, and then I add 8, that equals 41. All right, now I've got it simplified. It's down to a two-step equation. The next step is to subtract 8 from both sides because I have to undo any addition or subtraction first. Those two cancel each other out, and I am left with, let's see, 11x equals 41 minus 8 is 33. Okay. Oh, that's 41 plus 8. My bad. Whoops. 41 plus 8. Holy cow. Oh, my mistake again. That's supposed to be minus 8, just like the other side. Holy moly. So I was right the first time. It is 33. Okay, now we can do this. And so we're going to divide both sides by 11. And those will cancel each other out, leaving me with x equals 33 divided by 11, which is 3. Now, make sure that you check your work by taking that 3 and putting it back in for x into your original equation. All right, moving right along. Now, these next couple of questions are quite interesting because you'll notice that there is a constant on both sides of the equal sign, which is no big deal. You've seen those before, but you'll see that there's a term on both sides that has coefficient and a variable, both 5x and 8x. They're on both sides of the equation. So what we're going to do is we want to make sure that we have all the stuff with variables on one side of our equation and all the constants on the other side. So what I'm going to do is I'm going to subtract 5x from both sides. Now the reason I do that is so I don't end up with a negative x, but let's not worry about that for right now. I'm going to do that. Now I'm going to have on this side 4 equals 3 plus, and 8x minus 5x is 3x. You see? Okay. Now what I want to do is I want to get this variable, or sorry, not this variable, my bad. It is our constant. I want to get it to the other side. So I'm going to subtract 3 from both sides. So when I do that, that cancels out on that side. I get 3x on this side, and 4 minus 3 is 1. All right, now I have 1 equals 3x. My step is to divide both sides by 3. Those two cancel each other out, and I get x here. X equals 1/3. I don't have to divide 1 by 3. I can leave it as a fraction, and that's perfectly fine. Now, my final step that I like to do is I like to make sure that my variable is on one side of the equation and my answer is on the other, because I hate having the x on the right-hand side. So, got to make sure that when we start these questions, we want to take all the variables and move them to one side using proper algebraic movements, okay? We have to, so I subtracted 5x from both sides to eliminate the variable on one side, and then I subtracted the constant 3 from both sides, so I moved all the constants to one side. Piece of cake, no problem. And we ended up with x equals 1/3. You can take that 1/3 and put it back into the original equation if you like, and see if you get the correct answer. Our next one here is 3a plus 12 equals 5a plus 7. Okay? 3a plus 12 equals 5a plus 7. Okay, remember, first step, get all the variables from one side to the other. I'm going to subtract the smaller one from both sides, the 3a, so that I get a positive variable on the other side. When I do that, I get 12 equals 5a minus 3a is 2a plus 7. Now I subtract 7 from both sides. Subtract those constants. Those cancel out. 12 minus 7 is 5 equals 2a. And now my next step, divide both sides by 2, because I got to get that variable by itself. Those cancel out, and a equals 5/2. Or a equals 5/2. Now, if you really want to, you can change that to a mixed number, which would be 2.5. Okay, I believe this is our last one, so let's take a look really quick. 8 minus 3y equals 7y minus 2 minus 5y. Okay, well, first things first. Let's get all the y's together on this side. 7y minus 5y minus 2. 8 minus 3y over here. 7y minus 5y is 2y minus 2. 8 minus 3y. I'm going to move my variables to one side. Notice how this is a subtraction. I'm going to add the 3y to both sides. Cancels out. I get 8 over here. 2y plus 3y is 5y minus 2. Add 2 to both sides. I get 10 equals 5y. Divide both sides by 5. Those cancel. I get y equals 10 divided by 5, which is 2. Y equals 2. And of course, you can check your work by substituting it back into your original equation every time there's a y, and we're good. Thank you. Don't forget to be awesome and have a great day. See you next time.